Rất khó ý.
Các bạn lớp B à? Vâng, lớp B. Lớp B này. Cao, có bạn nào thì nhảy nhiều hơn? Dưới 10 em không được nhiều. Có bạn
Ở nhiều không có nhưng mà có gì. Vào đây.
có vài bạn không có bạn nào đang quay video rồi.
So, okay, in the meantime, how to change everything to the left screen. On what I will be talking and writing to you. So how about last week? We talked about the improper integrand of type 1, which means we have three cases from a to infinity, and then from minus infinity to b, and the last one from minus infinity to plus infinity, f(x) dx, which we have to understand that this is two cases. We split up into two a and b form integral. So this is what you have in the remark of your lecture, and I already explained this remark last week. So I skip for writing today, and you look at this. Pay attention. This is by definition. Both are conversion. Then you have a conversion of the first, the C type. But if either of these two improper integrand diverge, then we have the divergence of the given integrand. And I already talked about the count example when we consider f(x) is x. And if you take t as tend to infinity, and you take the integrand from minus t to tx dx, then it is wrong. Okay? So pay attention of that thing. And now we move to a very important and useful, the so-called improper integrand. So now we look at the case when we want to talk about the integrand of the first kind from 1 to infinity, 1 over xp dx. 1 over xp dx. Okay? So what we already know, if b equal to 2, you have convergence. Right? We already talked about from the beginning of this integral. If b equal to 1, you have divergence. So the question is, if b is not 1, not 2, how about conversion or diversion? So this result you can use freely. You don't have to reprove it. So then you have the result. Integral from 1 to infinity, 1 over xp dx is convergence. If b bigger than 1 and I is 1 over p minus 1, and divergent if p less than or equal to 1. So this very interesting result. We can write IP, for example, here. Okay, IP. So then for p equal to 2, you have already the case. See, you have already the case p bigger than 1. Then you have a convergence, right? Oh, that left I cannot show on the left. Hey, interesting. Okay, so this one, and that you have convergence p equal to 1 divergent. Okay? How to prove it? Now we prove this easy result, useful result, easy, and we see to work with improper integral. Okay, by definition, this is the limit of integral from 1 to t dx over x to power p, and let t tend to infinity, right? So what is that? This is xp plus 1 over p plus 1. If we want to take, oh my god, what happened right here? So you see, look at that. What is that? This is x to power alpha. Integral dx is x alpha plus 1 over alpha plus 1. Alpha different from negative 1. Right? Here, your case, alpha is negative p. Different from negative 1 means that p different from 1. Yes, because p equal to 1, we already considered. Right? Then, you have this one, negative p plus 1 as alpha and x from 1 to t. Right? Alright? So, then, what we have? You take negative p plus 1 out, and here you have t tend to infinity. Then t tend to infinity, x to power negative p plus 1, computing from 1 to t. So then you have t to 1 minus p minus 1. Agree? So you have that. 1 minus p. T to 1 minus p. If then it be less than 1, then 1 minus p positive and t to 1 minus p tend to infinity as t tend to infinity. In case p bigger than 1, 1 minus p less than 0, then t 1 minus p tend to 0 as t tend to infinity. So, from that, you get the answer. If p less than 1, you have infinity as a result. So it diverges. But if p bigger than 1, you have the result this tend to 0 and 1 negative 1 over 1 minus p is 1 over p minus 1. But you have the result, what we mentioned. See? So this very important and interesting theorem whose proof is quite easy. Just straightforward, using the definition. Okay? So, now, something happened with again technology, which I don't like
Technology.
in this auditorium. At this auditorium, I don't talk about the university. But I cannot use every time. Okay. So, now we move on technician display. What to do? I cannot show my slide for you. Then I have to use this one. Oh, what happened? Let's see. If I do like that, can you see or not? Not bad. Not bad, right? Yeah. So, are you like that? I use my... Can you fix it? That's why I keep one hand my laptop and the other hand I write. No, I cannot write here. Are you saying?
Technology. Sungguh juga teknologi.